So you've got a table of customer records, a few hundred rows, name, company, city, country, and someone on the sales team asks which of your customers are based in South American countries. And you can write that query, but you have to name every South American country yourself. And if you forget one, those customers quietly disappear from the answer. Then someone asks a harder one. Which of these companies sound like they might be in consulting? And now there's no query at all, because that isn't something a table stores. The information is sitting right there in your rows, and the fix is to stop searching the table and start searching what the rows mean. Here's the way to see it. Picture a paper form, the kind you fill in at an office, one short answer per box, no sentences anywhere. Every fact you need is on that form, but it's arranged for a filing cabinet, and nobody reads a form. You scan it for the box you came for. Now take those same boxes and write them out as a sentence instead, and a person can read it top to bottom and understand what this record is about. Now that comparison breaks in one place, because when you read a form, you already know what each box is for, and the model doesn't, so the labels have to travel with the values. So what goes wrong if you take that spreadsheet and throw it at a normal document pipeline, the same one you would use on a PDF? That pipeline treats everything as one long stream of text and cuts it into chunks by character count, because with running prose, that's the best you can do. Do that to a table, and you get chunks that end halfway through one customer and start halfway through the next, half an address, somebody else's phone number. And every one of those chunks is a mix of two people who have nothing to do with each other, so not one of them means anything. But look at what you're throwing away there. A spreadsheet already told you where the boundaries are, and every row is one complete thing. So that's the whole first move, one row, one record. You stop deciding where to cut, because whoever designed the table already decided for you. But a row still isn't something you can search by meaning, because a row is a set of boxes, so what has to happen to it first? You turn it into text. You take the fields, and you write them out into one readable line, and that step has a name. It's called field serialization. So a customer record with a first name, a last name, a company, a city, and a country comes out as a short piece of text you could read out loud. Something like this. First name, Cheryl. Last name, Baxter. Company, Rasmussen Group. City, East Leonard. Country, Chile. Same information the row had, now written so a reader can follow it. That's giving the row a voice. It was silent data before, columns and values, and now it's a description of something, which is what an embedding model can work with. And once you've given the row a voice, the rest is standard. That line becomes an embedding, which is a long list of numbers standing in for its meaning. And the numbers are arranged so records about similar things land near each other, so every customer ends up as a point on a map you can search by distance. Now, does it actually matter how you write that line? Because you have a real choice there, and it's the choice that decides whether any of this works. The lazy version is to paste the values together and stop thinking. Cheryl Baxter Rasmussen Group, East Leonard, Chile. Every value is in there, and nothing says what any of them is. Read that back as a stranger and try to answer one question. Is Rasmussen Group a company or a city? And is Chile a country or a family name? You can't tell from that line, and the embedding model can't either, so it has to guess from the words alone, and sometimes it will guess wrong. So keep the labels on. Put the field name in front of every value. So the line says company, Rasmussen Group, and country, Chile, and the guessing stops. Because now the model knows Chile is a country, and that single fact is what lets it connect this record to a question about South American nations. There's a third level, where you build a real sentence. Cheryl Baxter works at Rasmussen Group in East Leonard, Chile. That reads better than anything the other two produce. For most tables, keeping the labels on is the right place to stop, because the labeled line costs you nothing extra, and the handwritten sentence costs you a new template for every table you own. So every row is on that map now. What does that actually buy you at the moment somebody asks a question? The question goes through the same transformation the rows went through, because a position on a map only means something if everything is plotted on the same map. Then you take the record sitting closest to the question, and because it's one row, one record, every piece you pull back is a complete customer. Those few rows go to the model along with your original question, and the model reads them and writes the answer out of what they say. So go back to the question we started with. Which of your customers are based in South American countries? And watch what you didn't have to do. You never named a single country. The words South America appear nowhere in that table, and the Chile record still comes back, because on that map, Chile sits near South America. And the fuzzy question from the start works the same way. Ask for companies that sound like consulting, and Rasmussen Group comes back, because the word group carries meaning the search can use. That's the thing you couldn't do before. A table search finds what is written in it, and a meaning search finds what is implied by it. And if this feels lighter than you expected, that's the honest reaction. And it is lighter because the hardest decision in Document RAG, where to cut, was made for you by whoever built the table. The one place it gets expensive is size. Every row needs its own embedding. So a table with 100,000 rows is 100,000 embedding calls before you answer anything. That's a one-time cost. You pay it when you build the index, and not on every question, but on a big table, it's worth knowing about before you start. Now, let me save you some time here, because there are questions you should not send through any of this at all. If the question is a lookup, find me the customer with this exact ID, don't build any of this, because a database answers that instantly, and it's never approximately right. And it can't do arithmetic either. Ask for the average subscription date across your customers, and all you get back is the rows it found. Because retrieval is a search, and a search never adds anything up. So when the answer has to be computed, this is the wrong tool to reach for. So back to that sales question you couldn't answer. It was never a hard question. Your table had no way of being asked it in the first place. One row, one record. So you never have to decide where to cut. Then you give every row a voice by writing its fields out into a line of readable text. And you keep the labels on, so the model reads a labeled fact instead of guessing at a bare word. And now the table answers questions it never contained. So before you build anything, take one row from your own table, serialize it, and read it back as if you'd never seen the schema. If you can't tell what a value is meant to be, the model can't either. And that one check will save you a lot of confused results later. The working notebook for this one is in the RAG Techniques repository, and the link is below, along with the chapter it came from. And I make these to take the new complicated corners of AI and explain them until they actually click. So if that's what you're after, subscribe.